Over the past few months of learning Godot, I've been coming to the humbling realization that the more I know, the more I realize I don't know. Variations of this quote seem to have been attributed to Aristotle or Albert Einstein, although concrete sources on old quotes are always difficult to fully verify. In my case, the more I learn about software and game development, the more I realized I've only scratched the surface and how much more there is to learn. Another example of this effect is the Dunning-Kruger effect, as described by Dunning-Kruger in their 1999 humorously titled paper, Unskilled and Unaware of It, which describes the inverse of the previous quote, as people with limited knowledge in a topic tend to overestimate their level of skill. I can see this effect on my previous videos as there are more and more places I would like to update or change. I have found that nothing quite tests my understanding of programming like attempting to automate a task. Since it poses such a challenge, automation can be a great way to learn a lot about a new software or framework. As such, I have learned it's important to automate early and automate often to learn more as well as avoiding future problems. By the end of this video, hopefully I'll be able to convince you that automation is always a great priority for game development. As any good Factorio player can tell you, why spend 5 minutes doing something manually when you could spend 5 hours automating it? Besides the humorous idea of spending more time automating a task than it would have taken to complete the task manually, please see XKCD automation number 1319 for reference. Automation comes with many benefits over doing a task manually. I believe automating building and validation of a project via continuous integration and deployment should always be the first step in development. I'll be calling it CI/CD for short. Why not prototype, design, or playtest first? Well, 1, you can learn a lot from automation. 2, it's usually faster and more reliable. And 3, perhaps most importantly, you can avoid shooting yourself in the foot. In the past few months, I've been attempting to translate my OpenKCC project from the Unity game engine to Godot. The first task I worked on while porting my project was to automate the CI/CD pipeline. It helped me learn a lot about how Godot works and the differences and similarities between Godot and Unity, much more than attempting just a simple basic project. Learning to set up this automation and getting it work reliably would take some time. However, from my experience working on enterprise software and development for my day job, I knew it would be worth the investment. I've been using the word automation many times in this script so far, so let's define the term and get everyone on the same page. Automation in any computer software is taking a task that is normally performed by a human and programming those steps such that they can be done with little to no human interaction as well as some set of configurations. A common application of this is the previously mentioned CI/CD of a project of a platform like Azure, DevOps, or GitHub. This includes automatically building, testing, and then deploying software to end users. CI/CD allows updates made by developers to be sent to users as soon as the changes are made, hence the name continuous integration, which means testing and deployment. This decreases the delay between code changes and production servers. This is often seen in games as developers pushing updates or patches to the users as soon as the developers have a build ready, without having to manually upload the file to lots and lots of servers. Lots of software on your device that you're watching this video from probably use this strategy as well. Think about how often you open up Discord, Steam, or whatever browser you use and see that little updating message before you're able to use them. For me, it happens almost every time I open these programs. That's because they can deliver patches and changes with every fix the developers make to the codebase. Now, ask yourself, how often do these updates break something? Sometimes, but hopefully a patch doesn't crash your game. Automation can help ensure updates go smoothly and don't break things, if done well. Silicon Valley has a motto of go fast and break things. But what if you could still go fast and only sometimes break things? So I brought up some reasons of why to automate earlier. Let's dive into each of those. You can learn a lot when automating a task as opposed to completing it manually. When I complete a task once, I usually just have a surface level understanding of how it works. Needing to automate the task forces me to understand all parts of it. What are the inputs? What are the outputs? Where can things break and go wrong? And what to do in those scenarios. As an example, exporting a game once from Godot to any platform like Windows is relatively simple. You just gotta check the right buttons. However, automating that process to work on any machine from multiple platforms requires learning quite a bit more. What dependencies are needed for the game engine? What options are needed from the scripts to avoid duplicating code? You don't want to have to write the same block of code to build for Linux or Windows or Apple. And every time something's updated in the project, you want to make sure that those changes carry over to every build, not just one of them. Otherwise, you'd be spending a lot of time updating duplicate chunks of code. Speaking of saving time, I would argue that it's usually faster to automate tasks in software development than completing them manually. Despite that very compelling XKCD comic from earlier, if you're able to avoid scope creep, you can benefit from an extremely fast speed of computers. Even if a task is slowed, like image processing, using automation and scripting can complete a task from start to finish and be much more efficient than relying on a human to complete each individual step. I like using Python and PowerShell for joining together a bunch of programs. An example of this is when I needed to download a bunch of images from a database and get them all to be the same resolution. Downloading an individual image and cropping it with GIMP is quick, but having to do this 1,000 times is not. So automating the task was able to significantly save me some time, as I was able to run it in the background and work on other things while all those images downloaded and were resized. Running tests on my project is something else that suffers from this problem as well. If I think something should work, I probably won't manually test it, especially if I make what I feel is an unrelated change. There's so many times I would probably skip running tests in the project if it weren't automated with CI/CD. And then skipping these tests can sometimes lead to breaking the game and causing unintended problems. Having a very high throughput of updates and requiring every one of them to have manual inspection and verification of every feature would slow down a problem significantly. I mean, imagine if you had released a game and there was a gold duplication glitch that was discovered and the patch to fix it took weeks to roll out. I mean, you don't need to imagine it. You can just look at the launch of games like New World. Speaking of breaking things, automating tasks can help you from shooting yourself in the foot as well. Some tasks while making a game need to be done quite infrequently. The example that I sometimes have is baking a light map. It only needs to happen when you update a level or getting ready for a release. Since this process is not done too often, I sometimes forget all the different options, parameters, and steps involved in baking a light map. And lighting is something that I need to get right if I don't want my game looking weird. Automating that process, or at the very least keeping very detailed notes, can help make sure that the task is done the same way every time. That way, new levels don't look significantly different from old levels, and if I make any updates to the process, I can quickly apply it to all the levels. Speaking of documenting your work, we've all heard of that spaghetti mess of a code base that is a decade old and where fixing a bug causes something entirely unrelated to break. Sometimes bring to my mind the quote, "Back when I wrote this code, only God and I knew how it worked. Now, only God knows." If you automated a task, you can at least have that script to still run and complete it. And as long as that script runs and works, you're good. Leave the black box closed. If not, you learned how to do it once. You probably have some notes left and can repeat that same process of learning. Learn new things, right? So, now you know why you should automate, but next question is, which tasks would benefit the most from automation? All of them. No, really, always. The answer is always. Kind of. So, let's talk about what kind of tasks would be the best candidates for automation in game development. These would involve any tasks that require precision, are done frequently, or just kind of boring and mundane tasks. They're all the best candidates for automation. Precision is important because humans make mistakes, and automation can help make sure that a task is reliably done the same way each time. Think of those light maps from earlier. Frequent tasks also benefit from automation as they're done extremely often. An example of this is what I had mentioned earlier, when I needed to convert a bunch of images from one format to another, or change their resolution. I could open each file in the image editor, modify them by hand, and if it's a simple task, I can save a lot of time by just writing a simple Python script to do this. Finally, those boring and mundane tasks that I probably would have skipped anyway, I don't want to run all those unit tests every time I open the project, and I'll probably just end up skipping them eventually. Automation helps sure that all these tasks are run to completion and not skipped. Now, these are some good reasons to automate the task, but this brings up the question. what are some kinds of tasks that wouldn't be good from automation? Now, I know I said always before, but that was a bit of an exaggeration. There are some reasons to not automate a workflow. So these would include something that's a temporary change or changing very often. I mean, there's no reason to automate a workflow that you're only using once. Although, remember, there's nothing more permanent than a temporary solution. Also, out-of-scope tasks can be skipped for automation, as if they are truly different every time you run them, or if it's just something that can't be easily automated because, for some reason, you can't get the parts to talk together with the script, it's alright to manually follow those steps. An example of when I ran into this was rigging kind of basic placeholder animations for characters. I'm not a 3D artist or animator, but sometimes I use Mixamo to help with getting some basic animations set up for characters. It's a service provided by Adobe that lets you rig 3D models of basic humanoid skeletons and use some placeholder animations. Automating the process of uploading, rigging, and animating all these models would be quite difficult, as each model requires a different bit of fine-tuning and animations to make sure that they look right. And trying to get all of that to work together with scripts and all the very complicated parts that go together is just not worth the time investment, and that is a task that is easier to done manually than automated. So, we've been doing a lot of talking about theories and ideas. Let's dive into an example of where I use automation in my own projects. My projects are mostly hosted on GitHub, which has a nice feature called GitHub Actions, to run scripts or whatever else a developer needs to make whenever they have a change in the project. I use this to build the demo of most of my projects, upload a website, create documentation, run tests, and ensure that the code is maintained to a certain level of cleanliness or linting. Using this automated validation and building, I can verify that my changes don't break the game. If these tests and validations pass, then I can automatically build the game and upload it to my website. I mean, it would be really embarrassing if I had a presentation scheduled for some day and had everything break just because I didn't want to run some tests. Or so a friend told me. All of these automation steps can also be run locally on my own machine using bash scripts. So let's walk through that workflow of building and pushing a website with Godot. It's one of the most important workflows that I use for my projects. The first step in the workflow is to compile all the scripts for the project. While learning about Godot, I had learned about something called GD extensions, which allows you to have C++ support, and it requires pre-compiling all your C++ code first. This involves downloading all those dependencies and binaries for C++ code and Godot libraries. I found a great example of how to do this by Dmitry Slenikov, sorry if I mispronounce your name, and their project Debug Draw 3D. Although C++ and GD extensions would be a great topic for a future video, his existing example allowed me to easily set up a workflow that would compile the C++ libraries for various platforms. The next step to run in the Godot project was to set up unit testing. I decided to use the Godot unit test, or GUT project. As long as those unit tests pass, I know that I'm good to build and all the basic features should work. From there, I use the Godot's command line interface. I'm actually running these tests and building it with a Docker container. So Docker is a great tool for automation because it allows you to package a set of software and development environment and run it on any machine isolated from the underlying system. That way you don't have to download and install very specific versions of every piece of software and library that's required for your build toolchain. In my specific case, installing and running Godot on a server would actually take quite a bit of time, as you'd have to download all the various binaries, their dependencies, and make sure all those install scripts run and work. There were some very nice people that had made a project called Godot CI, which does this already for almost every single version of Godot. They uploaded this image to Docker Hub, so I can grab this Godot CI image for Docker Hub for my version of Godot, and then I'm instantly able to run any of those basic Godot commands to build versions of my project on any machine without having to install all the software there. Once the project's done building, I have my GitHub action take that exported project and upload it to a website using a service called GitHub Pages so that anybody can see it there. GitHub Pages is a built-in feature of GitHub that allows you to share small sites and documentation. It can't be used to share large files, but sharing a small demo and documentation of my projects are good use cases. Setting up all of these tasks Testing them and getting them to work together took quite a bit of time, and I still sometimes break them when I update them. Don't get discouraged if it takes you more than one attempt to automate a process. I might go into specific details of how I write GitHub Actions for automation in a future video, but feel free to look into any of my projects for a reference. I'll link to some good learning resources in the description as well. For the Unity version of my OpenKCC project, it's pretty much the same, but with a bit more validation and licensing because unlike Godot, Unity is not open source and requires a lot of software licenses to run properly. But there are some great people who set up some software environments called Game CI, and I use these in my projects. They also work with software like GitHub, GitLab, Circle CI. Unity is a bit more of a black box in how it runs, so you need to do everything using the Unity client. You can't use third-party tools to compile parts of your project like Godot. Speaking of using extra tools, while I was working with Godot, I always try to build web demos in my projects so users don't have to download binaries to see a simple example of the project. It was really neat learning how they compiled the web platform, as I was able to dive into the source code and find out what dependencies were converting all of my Godot project to WebAssembly. It's a bit of a topic for a future video, out of scope for automation video, but whenever I was doing this process of Unity, I just have to click a bunch of buttons, and it sometimes worked. There wasn't really a way for me to dive in and see what it was doing under the hood. Still, it's sometimes nice when things work and you don't have to do as much work to get it all cooperating, but it was very interesting learning all these different parts when working with Godot. This is just automation of my simple game demos. Larger games will require much more automation between pushing patches and hotfixes to users, which is actually quite a complicated task, sometimes involving uploading files to content delivery networks, getting builds approved by third parties, and hardest of all, getting multiple developers and stakeholders to agree on something. Any complex task like pushing updates server-side or pushing updates to beta test versions of users all greatly benefit from automation. Every patch and beta version that can be rolled out sooner allows you to prevent more bugs for players, and if that process is very long and complex, developers will probably avoid it at all costs. I know some games on Steam that do have beta versions, and some of them are updated very often. Some of these updates will be small patches, but sometimes they'll have many versions of updates between every major release of the game, allowing them to collect lots of data and fix many problems that users might encounter. The game Subnautica, during its early access phase, had a way for players to submit and report bugs, and then the developers could visualize these bugs on a heat map to see where players encountered the most problems in the game world. This helped developers understand the pain points in their game and take in large amounts of data that would have been almost impossible to process had they been going through each support ticket manually by hand. They have a great GDC talk on how they use this data if you're interested to learn more. I'll make sure to link it in the comments. If you do decide to include automation in your project, it's always useful to check if someone's already done something like you're trying to do before. This is a great part about open source projects, as you can look up what other people have already done and learn from their example. This is how I learned a lot about GD extensions in Godot. I had found that great example earlier from Dmitry Salinikov's Godot Debug Draw 3D project. Automation's not required for any individual project or game to go well, but it'll almost never hurt, and it can be a great tool. But don't get bogged down in letting perfect be the enemy of good enough. See that relevant XKCD from earlier. Manual steps and finishing touches can be useful in moderation. Just remember to keep a balance and avoid scope creep from taking over the project. Hopefully you can feel inspired to add automation to your next project, even if it's something simple like posting a cat GIF in response to a pull request or comment on the project. Shout out to the Action Cats project on GitHub. I'm still new to learning Godot, but as Dunning and Kruger stated in their own paper's concluding remarks, let us assure you that to the extent that this video is imperfect, it is not a sin that we have committed knowingly. Thanks for sticking around to the end of the video. I know it's been a while since I published something. This script took quite a few iterations to get through. I've been spending some time porting the OpenKCC project to Godot, at least the basics of it. It was difficult to port the logic at first, but hopefully I can make some nice content in the future as a follow-up. I'll try to keep future update videos with both Godot and Unity, even if I mostly focus on Godot in the future. I have been significantly busy over the past few months, and still have quite a bit of work left to do on the Godot project. I might make a few more of these side tangent-like videos that don't directly relate to something from the OpenKCC project, but instead talk about high-level topics, so make sure to subscribe if you're interested, and have a great day!